Assalamualaikum and greetings everyone. My name is Izzat Izzudin Bin Jefri, and today I'm gonna present to you about my final year project, which is the title of the project is Design, Build and Fly the Vertical Takeoff and Landing Vehicles. Okay, first of all, my supervisor name is TS Dr. Zuriati Muhammad Ali, and the co-supervisor is Dr. Zulhilmi Sah. Next, we're gonna go to the course summary. The Vertical Takeoff and Landing Vehicles, VTOL, is a new technology that has been discovered in the aircraft industry. The VTOL can be implemented into the radio control vehicle, or we known as RC. The VTOL RC is intended for any type of vertical takeoff and landing, which consists of from simple mati roto to more complex transitioning vehicles. It required coding for Arduino and Tensi 4.0. So Tensi 4.0 board is a very powerful microcontroller that allows coding run and execute at a very high speed. So in this project, this is the vertical takeoff and landing. I name it as Rhinos RC aircraft. Will be designed, built and fly. That is inspired by the Sukhoi Su-30M aircraft. Okay, we go to the introduction. Okay, what is VTOL or VTOL? VTOL, V vertical, T take, O off, and L landing. Vertical takeoff and landing is capabilities of a vehicle to hovering, takeoff and landing vertically. So the background of it, the first inventions, history of this VTOL were found in sketchbook of Leonardo da Vinci's sketchbook known as the Aerial Screw, which is the human-powered helicopters, as you can see in the photo. Okay, the history background of the VTOL. The first ever invention that used the VTOL technology is helicopters. The helicopters remain the first vehicles ever to successfully fly in a VTOL or vertical takeoff and landing styles. First ever recorded helicopters to ever fly is back in 1907. After World War II, there's a lot of design of the VTOL, including the Henry Berlinus horizontal rotor fix and the Nikola Tesla's 1928 patent. In the post-war event, spawned various types of variation in VTOL rotor design, such as the gyrocopter, as you can see here, and the gyrodyne. Next, I'm gonna go to the literature review. In this literature review, I reviewed different types of design of the fighter jets and the helicopters to be implemented and inspired into my Rhinos design. Okay, the first fighter jet is a F-35 Lightning II fighter jet. It is considered as one of the best fighter jets ever exist in its generation, which is the 5th generation of fighter jet. It has a great aerodynamic performance and advanced integrated avionics. The F-35 Lightning II can operate both in conventional takeoff and landing and the vertical takeoff and landing VTOL. The conventional takeoff and landing, which is the conventional types of aircraft, it require a long runway in order for them to fly, not like the vertical takeoff where it require just a space where they can take off and landing. Okay, for the VTOL features for the F-35 Lightning, there's a hole at the middle of the aircraft, and there's a turbofan on it where it can produce lift force when they turn on, and then it can produce a upward thrust, and then they can fly in vertical takeoff. And not just that, at the end of the engine of this fighter jet engine, the exhaust of it the angle can tilt a little bit so that it can push and stabilize the aircraft from behind of the exhaust. And the dimension of this fighter jet is with a wingspan of 10.7 meter, length of 15.7 meter, height of 4.28 meter, and have a performance with a maximum speed of 1,200 miles per hour or 1,930 kilometer per hour, and a flight range of 2,170 kilometer with a full tank of gas. Okay, next we're gonna go to the Bell Boeing V-22 Osprey, or the one that you can see here. It have a helicopter look-alike. Okay, it is a joint service, medium lift and a multi-mission tilt rotor. It is developed by both Boeing and Bell Helicopters Company, and it operate in vertical and takeoff landing, which is the VTOL, because it is classified as one of the helicopter for the US Air Force. When there are takeoff and landing, they take off and landing vertically, and then the rotor of the Osprey will go tilt 90 degree to push it forward or produce the forward force when they airborne, and converting it into a turboprop aircraft. And the performance of it, it has a maximum speed of 565 km per hour and have a flight range of 3,379 km. The next one is Sukhoi Su-30M fighter jet. It is a Russian fighter jet, which is built there, and it is a multi-role two-seater fighter jet, which is developed and designed by Sukhoi Design Bureau of Moscow and manufactured by Irkut Corporation. This fighter jet considered as one of the most beautiful fighter jet ever designed, because it looks very modern and futuristic. It operates in operates in vertical takeoff and landing, which is the VTOL, but it operates in conventional takeoff and landing, which is require a long runway in order for them to have a much lift force to fly. And the dimension of this Sukhoi Su-30M is it have a wingspan of 14.7 meter, a length of 23.335 meter, and a height of 6.355 meter, and have a performance of maximum speed 2,150 km per hour and a flight range 5,200 km with a fuel tank. And last but not least, about this Sukhoi Su-30M, fun fact about it is our Royal Malaysian Air Force (RMAF) have one of these as an asset. Next, we're gonna go to the problem statement and objective. The problem statement. There's two problem statement that I can state here, which is we lack of knowledge about the vertical takeoff and landing vehicles technology, and the second one is the lack of hands-on experience on this vertical takeoff and landing RC's vehicle. For the objective, there's three, which is to create and design the VTOL RC aircraft, to implement the technology of the VTOL into the RC aircraft, and the last one to study the characteristic and behavior of the VTOL RC aircraft during the flying process. The expected result: we expect to successfully design and build this vertical takeoff and landing radio control VTOL RC aircraft at the end of next semester of FYP 2, and the second one is we expect to fly the vertical takeoff and landing RC's vehicles, and this is both 3D drawing and 2D drawing, which is 2D is for the drafting and the dimension of my VTOL RC design. That's all from me. Thank you. If you have any question, just hit me up to my Gmail, or you can call to my number as stated here. That's all from me. Thank you.